Hi everyone, this is Kiranmai from H&S department. Today in this topic, we are going to discuss about lasers and optical fiber applications. Applications of lasers in different fields we are going to discuss. Few of them are communication, industrial applications, medical applications, and military applications. Regarding optical fibers, we are going to see in three different fields, that is communication system, sensor field, and medical field. Now to the first application of lasers in communication field, we can use lasers in three different communication purposes. One is open space communication, fiber optic communication, and underwater communication. Open space communication, that is especially for the communication with the satellites, whereas a fiber optic communication, for the landlines, TV, transmit audio and both audio and video signals without any attenuation or distortion. Underwater communication is generally for the sea communication because lasers are not absorbed by the water. So coming to the open space communication, the angular speed of laser beam is very narrow, which recommends that laser beam can be used for the communication between Earth and Moon or to the other satellites. Whereas fiber optic communication, the lasers are used as light source to transmit the audio, video, and data to long distances without attenuation and distortion. Whereas in underwater communication, laser radiation is not absorbed by the water, so laser beam is used for inside sea communications. This is in case of communication system. Whereas when you go for the industrial applications of a laser, mainly it is used for the metal cutting, welding, drilling, and adjoining any two dissimilar metals. And most widely used in nowadays, most widely used in semiconductor industries, electronic industries, for the trimming of components in ICs. Metal cutting, for the bulk cutting of metallic materials or bulk cutting of cloth, in cloth industries, most of the time lasers are used for that purpose. Using laser techniques, cutting materials such as metal sheets, cloths is very easy. In mass production of stitched clothes, the cutting in the desired dimension is done by stock filling a large number of cloth material and cutting them all at once by exposing laser beam. Welding means a laser beam exposed to a place where the welding has to be done. At that place, the material melts down, and due to heat produced by the beam and on cooling the material, makes the stronger joint. And for drilling purpose, when a large beam of laser is focused on a very small area, the laser light energy is converted into heat energy so that the material can be heated up, melted, and evaporated. Using these techniques, holes can be drilled in steel, ceramic, diamond, and on alloys also. Whereas in this, adjoining the two dissimilar metals can be welded and micro welded is done with a great ease using lasers. Then coming to the medical applications, n number of medical applications are there for the lasers. But the first and more prominent one is eye surgeries, that is by ophthalmologists. They use it for the especially in detached retinas, eye surgeries for the detached retina. The retina can be attached to the choroid by heating it over a number of spots. The heating can be achieved by focusing laser beam of predetermined intensity on the retina. This can be done by using argon ion lasers. The second application of laser in medical field is angioplasty, that is plastic surgeries for the treatment of skin injuries, and this can be done using Nd:Ag lasers. And the other application is dermatologist for the treatment of skin tissues, like removing of moles or tattoos, to remove the tattoos, to deal with the tumors that are developed in the skin tissues. All this can be done using lasers. The other application of lasers in medical field is in stomatology, that is the study of mouth and its diseases. Mouth ulcers can be easily cured by exposing it to the laser beam. Lasers are also used to destroy kidney stones and gallstones. The laser pulse breaks those stones into small pieces. Lasers are used in cancer diagnosis and its therapy also. Lasers are used in blood lossless surgeries. Lasers are also used in control hemorrhage, and using organ and lasers, liver and lung treatment can be carried out. And lasers are also used in endoscopes to detect the hidden parts of our body. Next application of lasers is in military, where they are using mostly for the death rays, that is by focusing high energetic laser beams for few seconds to the aircraft, missiles can be destroyed. So they are called as death rays or war weapons. The other application is laser gun, that a vital part of the enemy body can be evaporated at short range by focusing high convergent laser beam from a laser gun. The other application is LIDAR, which is used for the detection and ranging of enemies objects. That is, this is used to estimate the size and shape of the distant objects or war weapons, and to guide missiles. Missiles also, lasers are used nowadays. Few other applications of lasers in computers, thermonuclear fusion, and scientific research are as follows. In computers, most of the time, in computer printers, scanners, and also CD-ROM storage of capacity. Storage capacity can be increased using CD-ROMs. That also can be, data transformation can be done using lasers only. In thermonuclear fusion, since it need high temperatures to have that nuclear fission process, most of the time lasers are used for this purpose. And in scientific research, lasers are used to study the nature of chemical bonds, and also for the isotope separation, size and shape of biological cells, and to find out the size of dust particles, used for the recording and reconstruction of holograms, and also used for the development of hidden fingerprints, and to clean the delicate pieces of art. These are the few applications where we can apply lasers very predominantly. Next, we are going to see the applications of optical fibers in different fields. But the thing is, you can apply optical fibers in many fields wherever you find the application for lasers, because lasers need a medium waveguide to travel from one medium to another medium, one place to another place. That waveguide is an optical fiber cable. So wherever you find the laser applications, you can apply optical fibers over there. But in this session, we are going to see three important applications of optical fibers, that is fiber optic communication, medical application, and also in sensors. Fiber optic communication is nothing but the telecommunication area, include the voice telephones, video phones, telegraph services, various new services and data networks are also transmitted over common carrier links. Under medical application, we are going to see endoscopic applications. Under sensor field, we are going to see various kinds of sensors, like temperature sensor, pressure sensor in our session. First of all, fiber optic communication. How the signal will be communicated in a using a optical fiber. This fiber optic communication mainly consists of three parts. One is transmitter, then an optical fiber cable, and then a receiver. This optical fiber cable, we will call it as a carrier. So transmitter will send the signal, optical fiber will carry the signal, and receiver will receive the signal. These are the three important or crucial parts where the signal will be transferred from one place to another place. So the work of transmitter, this transmitter will have two circuits. One is driver circuit, another one is light source. Driver circuit, first of all, converts the signals, either converts the audio or video signals into electrical signals. Whatever the signal you are supposed to give at the input, that will be converted into a electrical signal using a driver circuit. Then the light source will convert this electrical signal into light signal. Most of the time, this light source will be an LED. Then coming to the optical fiber, it carries this light signal which is coming from the light source from one point to another point, and with less attenuation uh, to the other end. At the receiver end, first photodetector will detect the light radiations which are coming from the optical fiber cable. Those are fed to an amplifier which will strengthen that signal. Those amplified signals are given to a signal restorer or a transducer, which will finally convert that light signals into uh, electrical signals, and then electrical signals into a audio or video form signals. Then coming to the application of optical fibers in sensors, two different types of sensors will be there. One is an active sensor and the one is a passive sensor. In active sensors, physically an optical fiber can be used for the sensing purpose, whereas in passive sensors, we cannot use optical fiber for the sensing purpose, but it will be used for the guiding medium. guiding the signals from one point to another point. Active sensors is otherwise called as intrinsic sensors, whereas passive sensors are otherwise called as extrinsic sensors. Uh, Coming to the active sensor, the best example is an pressure sensor, where you are supposed to use an optical fiber cable to sense the pressure of the objects. The principle behind this pressure sensor is interference, that is the path difference between the reference beam and the beam passing through the environment, that will give you the pressure applied over there. High energy laser light from the source is made to fall on a beam splitter placed at angle of 45 degrees. Then this beam splitter splits that incident light into two components. One passes through the reference end, another passes through the environment end. Finally, the path difference between them will sense the change in pressure. Suppose you can see on the screen, there is one laser source, okay, which will provide you laser radiations. This will be passed through one splitter. This will split at this will be arranged at 45 degrees angle. So this will split the radiations into two parts. One will pass through the reference end. This will be reference end, and this was the measuring end. So two radiations will pass through two different ends and reaches the end point where where the difference between these two fibers will be measured, and indirectly it will be converted into pressure also. The next sensor is displacement sensor, is the best example for passive sensor, where we are not supposed to use optical fiber directly for sensing purpose. Here the light from the source is made to fall on the object. After passing through the transmitting fiber, the light reflected from the moving object is received by the receiving fiber, and the same is detected by the ore detector. The change in intensity of light measures the movement of the object. Increase of intensity of light resembles that object is moving towards the sensor, while the decrease in intensity of light resembles the object is moving away from the sensor. See, this is the sensor. This is a medium where optical fiber is made. The light is guided using it. This is the object. Okay, and if the object is moving towards the sensor, the detected light intensity will be high. If the object is moving away from the sensor, the detected light intensity will be less. Depending upon that, we can say whether the object is moving towards us or away from the source. The last and final applications of optical fiber in medical field is endoscopic applications, where one of the two main endoscopic cables carries light from the bright lamp in the operating room in the body into the body, illuminating the cavity where the endoscope has been inserted. And then the light bounces along the walls of the cable into the patient's body cavity. The diseased or injured part of the patient's body is illuminated by the light shining in. The light reflected off the body part travels back a separate fiber optic cable, bouncing off the glass walls as it goes. The light shines into the physician's eyes so he or she can see what's happening inside the patient's body. Sometimes optical fiber cable is directly connected into a video camera. Here on the screen, you can observe that there will be uh, two bundles of optical fiber cables will be there. One will be placed at the end of the source, another will be placed at the physician's eye, and the other end will be sent inside our body through the mouth. The light radiations will be sent through one bundle of optical fibers. They will be incident on the part which has to be examined, and the reflected rays from that part has been traveled through the other optical fiber bundle, and it will be monitored by the physician, or if it is connected to a monitor, there you can observe the status of the examined part, whether it is working properly or not. These are the some of the applications of optical fibers in different fields. Thank you.